Welcome to Blenderism, my friends. Well, as I promised, here is the second part of the training on modeling a Lamborghini Huracan. In this part, we will have a wheel, but without rubber. This will be the next part, since there is too much content for one time. I hope you understand me. So I suggest we get started. Let's start by deleting everything. And looking for a reference, placing the view at an angle of 90 degrees by pressing 1 on the numpad. Add our image. At this point, it is important to place the reference as much as possible in the center, and at an angle of 90 degrees. Since the final result depends on this. So we add a circle mesh and set it in the settings to 100 vertices. Now we can rotate it 90 degrees and place it opposite the reference and delete its vertices, leaving 11 pieces from which we will start modeling. We turn on modeling relative to the 3D cursor. We place our workpiece opposite the disc, and with simple movements we begin to create the shape of the disc. Another thing I would like to share with you is that you do not need to simply repeat what you see on the screen. I will try to explain to you how it works, and then it will become clear to you why you need to do such manipulations with our model. And so what do we have? As everyone knows, there are 360 degrees in a circle. Our machine disc has 10 spokes that go in a circle. We take this as a basis and count. If you take these 100 vertices and divide them into 5 pairs of spokes, you get 20 vertices per pair. Next, to optimize the process, we divide this pair in half. That is, we will model only one spoke, which we will mirror and then multiply the finished part in a circle. To start, we need 11 vertices and not 10. Since one is used for mirror reflection, well, we will make not only the spoke, but also the rim of the disc. Topology is a branch of mathematics that studies, roughly speaking, the continuity of forms. In 3D graphics, topology is the arrangement of polygons that creates a certain path along the surface of a polygonal mesh. Topology refers to the geometric characteristics of the surface of a 3D mesh. You can also come across the concept of polygon flow, a flow of polygons, but the arrangement of vertices and edges of the mesh also plays an important role in creating 3D models. We can say that in essence there are no clear standards or iron rules in working with topology. This is an area in which success can only be achieved through practice, analysis, and experience, being well read. In some ways, topology can be compared to learning a foreign language. Yes, you can come to another country without knowing its language, but you will definitely encounter problems and difficulties, and you will not get the result from the trip that you could have gotten if you knew the local language at least at a basic level. What is the importance of topology? Basically, it depends on the task facing the artist. In the case of hard surface modeling, good topology will allow us to make edits and change the geometry of the model easier and faster, select individual areas, work with clean and neat chamfers, and get a clean final result. In the case of modeling characters or creatures, the mesh will deform during animation, which means that in this case, the correct topology is important for correct and clean animation. It will make the animator's life easier and, again, will allow easy and quick work on edits and changes to the model mesh. From all this, we can conclude that the cleaner and more correct the topology of the model, the easier it is for us to control and predict the final result, avoid unpleasant artifacts, and also save ourselves a lot of time by eliminating useless actions from the workflow. What does a 3D model consist of? Any model will consist of 3 elements: a polygon, an edge, a vertex. Polygon, edge, vertex. You will often, always, hear the following designations: vertex, edge, polygon. Vertex is the position of a point in 3-dimensional space, which is determined by the coordinates x, y, z. It can store such information as color, normal direction, texture coordinates. Several edges and polygons can have one vertex. Edge is a line that connects two vertices. As in the case of a vertex, several polygons can have a common edge. It is important. It is better not to call them lines and immediately get used to the concept of edge. Polygon. A polygon consists of three or more vertices with a closed contour of edges. This is exactly the shape that defines the surface of a three-dimensional mesh. Polygon flow. Remember this concept, right? A polygon is also called a face, a surface. Usually, a 3D mesh contains from tens to hundreds and thousands of polygons. It depends on the task for which we make our model. The well-known concept of optimization also includes the number of polygons, or, more precisely, triangles, included in the mesh. It can often be strictly limited to the requirements of the project, in the case of games. Every year these requirements become more and more blurred, thanks to the development of computing technologies. But, this is not the only aspect of optimization. Polygons are named based on their number of sides. Let's highlight three types that you will encounter most often: triangle, triangle, a three-sided polygon, in other words, a triangle. You will encounter this concept very often, since a triangle is the basic form of a polygon used, for example, by engines. There is also a triangulation process, dividing the quads of a model into triangles. We usually do this before unloading the model for baking. The engines, in turn, do the triangulation themselves, if it is not done in advance. Quadrangle, quad, a polygon with four sides. This is the type of polygon that we should know, love and respect, since it is the basis of our model when creating its mesh. Pentagon, a polygon with more than four sides. Important: if you see a quad with 5 vertices, then this is already an n-gon, despite the fact that visually it is square. There are a number of opinions in the 3D community on the topic of using n-gon and triangle polygons in creating a model. In fact, everything depends on the situation and the goals for which the model is created. A separate topic is models for animation, for example, characters. They have a number of their own, special requirements for the use of polygons in topology. Let's take the following principle as a basis: what I can do does not mean that it should be so, and we will strive to build our grids on quad, square polygons. Let's remember that an even and convenient grid is the key to ease and speed of its editing. A square polygon in this situation is our main assistant. Of course, there are situations when other types of polygons are used, but this is situational. It becomes clearer with experience, and already on specific examples you will need to look and decide which polygon to use. Planar and non-planar polygons, flat and non-planar. A polygon is planar if all its vertices lie in the same plane. Also, a triangular polygon is planar, since its 3 vertices will always lie in the same plane. Most polygons in your models will be planar, lie with their vertices in the same plane. In turn, a non-planar polygon will be considered a polygon in which one or more vertices do not lie in the plane with the others, creating a bend. When working with topology, it is worth remembering that there is a process of triangulation of models. We talked about it above. In essence, this is dividing your quads into triangles with a diagonal edge. Any engine requires that the model be triangulated for its correct display, or does it itself. In the case of non-planar polygons, this can create artifacts on the surface of the model, since triangulation on such polygons can lie arbitrarily, without taking into account their deformation axis. This is solved by manually editing the triangulation. It should go along the deformation axis of the polygon that you initially laid down when deforming it, and not according to the logic that the engine chose. Subdivision surface is a surface subdivision algorithm that creates a smooth surface from a rough, polygonal mesh. When the mesh is subdivided, it becomes smoother, its details take on a more final appearance. This transformation is reversible only if you do not apply final smoothing, for example, before unloading high poly for baking. The most commonly used subdivision surface algorithm is Catmull, Clark, CC sub D. It was developed by Edwin Catmull and James Clark in 1978. Note how long ago a successful idea became a relevant tool to this day. In simple terms, its essence is that centroids are placed on the polygons of the model under sub D, vertices at the center points of the polygons. Then they are connected by edges, the remaining vertices are shifted to relieve stress, the shape is rounded. This algorithm is iterative, that is, it can be repeated over and over, increasing the number of subdivisions. Thus, we get a high poly model, and it is this process that we need to take into account when building a model for sub D. Clean and neat work with topology under subdivision surface is a guarantee that you will get the correct model without artifacts at the output, high density, chaos in the construction of the grid, inconsistency in polygons. All this can create a lot of difficulties for you in the modeling process and turn it into hard, exhausting work. But we want to enjoy the process and be creative, and not rake up a pile of polygons, right? Important definitions and concepts of topology that you need to know and take into account. Polyloop, a loop of polygons. It is a set of sequentially and continuously connected square polygons. Polyloop is an important element in building a 3D model. The ability to work with loops will be the key to your success. One polygon by itself means nothing, since thinking in this format we do not see codependencies, we can miss important points in the model, or make construction errors. But a closed chain of polygons is a powerful tool that allows you to think and model more comprehensively. You should immediately, from the very beginning, try to think in loops, and not in separate polygons when creating your grids. Polyloop allows you to distribute polygons more accurately and evenly, select individual sections and edit the model. When using sub D, correct polyloops are subdivided and smoothed best of all. This is why you should immediately, in advance, plan your work and try to think comprehensively. The right start to work is a guarantee that at the final stages you will save yourself a lot of time and effort. In different situations, polyloops work differently with sub D, which is why you need practice and experience to see and remember different situations. Look at different examples of meshes, try to see these loops, and soon you will understand that indeed, each model consists primarily of them. Edge loop, in turn, is a loop of edges. As with polyloop, an edge loop is a cut that you will make on the model, and they will close. Correct work with the placement of such loops is also the key to a clean, light mesh that will be correctly smoothed and easy to edit. Pay attention to the image above, it shows both polygon loops and edge loops. In fact, these are inseparable concepts, but each of them is important in itself and can have a different function. Depending on the task, there are also situations when the edge loop ends in a star, they are also called poles. We will talk about this further. Each edge loop is designed to serve the shape of your object. Look at the position of the loops in your model and tell yourself, which of them serve a function and which do not. This will show you where you have done unnecessary work. When working with edge loop, it is also worth thinking in loops, not individual edges. Well, at this point we can consider that our part is ready. So we need to start reproducing it. It's not difficult. But for this we need to remember the geometry material for the 5th grade. If we divide 360 degrees of a circle into 5 pairs of spokes, we will get 72 degrees occupied by one spoke. That is, we need to copy our part and rotate it relative to the 3D point by 72 degrees. And if you connect 2 parts, then in order to move them, you will need to rotate them by 144 degrees. Well, and one more detail. When ready, you can connect them. Well, and add the welding modifier. As you can see, not everything is perfectly connected, so you need to fix it a little using the M button to merge them. To avoid this kind of problem, you need to create the first part ideally, so we strive for the ideal shape. At this point we need to select all and make it by distance merge. We need this to make correct geometry. Also go to Loop Tools and apply Circle to this edges one and by one. So now we can select this two edge loops and make bridge among them. And immediately, without cancelling the selection, compress the edges using the letter S. Okay, we good. So now we can select another edges and make them bevel, but first we need to dissolve few edges we don't need them. And we need to make place for a tire. So we need to give another cut here, so press Ctrl or decrease amount to 1 and use Alt E to extrude along normals. Also let's give another bevel to this two inner edges to make them sharper. Okay, now our model more looks like wheel disc. So now we need to finish with these elements. This is the hole for the bolts and the central part of the disc. They should be wider. To connect circles you better use grid fill, then simple F button, it gives better topology. As I understand the minimum length of the bolt or even more, so let's extend the edges and close it all with a lid. So ladies and gentlemen, lovers of spending time in a blender, we are doing very well. I would say that we have passed the most difficult part. Now everything will go more pleasantly. I suggest adding bolts. To do this, you must have the bolts add-on enabled. That's what it's called. This is a very useful thing. It has both bolts and nuts of different sizes and types. Here you can choose what we need. I know that cars are equipped with bolts with secrets so that they cannot be unscrewed without the right key. Let's choose something similar. And we don't need the part with the thread because it won't be visible, and we want to reduce the number of faces in the scene, so we delete it. Now we can adjust it to size, turn it over and install it in place. so we move on to the brake disc. We add a circle mesh and immediately in the menu on the bottom left we set the number of vertices to 200, well, or quite a lot, because we will need to make screw holes and this requires a large number of vertices, so we additionally subdivide our disc also across, at least 10 times. Now we'll go back to the 5th grade and remember our geometry lessons. I suggest we conduct a small survey, press pause, and who remembers the name of their math teacher? Write in the comments so I'll at least understand that you're listening to me. I'm trying for all of us, ha ha ha. Okay, let's get back to business. We delete the lower part, the right part and half of what remains. If we draw a bisector it will pass at 45 degrees, for this you can use the stage grid. Or take a cube, connect the opposite vertices diagonally, delete half and get a regular triangle whose long side will be at an angle of 45 degrees. In general, using the Alt button, select the faces, using Ctrl and plus, add a selection and delete half. Now you need to select the faces to which we will apply the loop tool and make ventilation holes. I will speed up this process a little if you do not mind. When everything is selected, press Insert, you can twice for a stronger structure. Set the thickness, select everything and extrude along the Y-axis. Here you need to delete the side faces as they are not needed and will even interfere in the places where the objects are connected. So delete them right away. When you are ready, you can multiply the part. First, use the mirror modifier. And then turn on the transformation relative to the 3D cursor and, as we did earlier, copy and rotate only by 90 degrees. Bam, and the part is ready, everything is fine with us. If you want, you can add a welding modifier to be sure. Now you can install the brake disc calmly. So now you can move on to the decorative thing in the form of a chain. To do this, create one link and multiply it. Add the almighty cube, subdivide it into parts, give it the desired shape. In the process, give it a bevel modifier. Add a cylinder, give it a mirror and bevel modifier. Now you can connect all this. You always need to think ahead and plan, so here I will immediately paint this piece of the chain, so that you don't have to do this for each object. Well, in order to run this piece of the chain in a circle, we add an array modifier and a curve to it. Well, the next element can be mounted in place. When you are ready, you can apply modifiers so that the chain is ready as one mesh. So, let's move on to shading. We need to paint the brake disc and make circular marks from the brake pads. And so for this we need to add a new material and set the BSDF metal to 1 in the principle, then add color ramp, noise texture and texture coordinates. Connect the factor to the factor, color to color and object to vector. Next, since the Mossgrave texture was removed in update 4.1, we will use the noise texture. Copy the color ramp and swap the gray and white sliders. Do not forget to uncheck the normalize box. And use the settings as on the screen. Then add a color mix and mix these two textures. At this point, it's ready, you can always adjust it if necessary. Let's move on to the second material. Add another one by clicking on the plus sign. Add 2 color ramps, make color settings as on the screen, add a noise texture, color mix, gradient texture, texture coordinates and do not forget to switch to spherical in the gradient texture. Connect it all. To visualize what is happening, you need to select those faces to which this material will be applied, traces of brake pads. As you can see, I use a combination of Ctrl and plus to select, and it selects from both sides, so you need to cancel the selection on one side that will not be visible. Of course, it is not critical, but we strive to ensure that everything is correct. And we apply the second material. We connect everything and when we set the scale to 1200 we can see the result. We connect the second color ramp to roughness and bump to normal. We set the bump to a very small value and add metallicity. And now you can correct the color and roughness. I'll go over the disk material quickly. I downloaded a library of assets and this machine paint was there, so I apply it to the disks. I like the metal particles inside the paint. I'll show you the node system. You can use print screen to take a photo. I advise you to create a library of materials or assets that you use. Well, let's move on to the brakes. There's nothing out of the ordinary here. Add a pre-prepared reference. Add a plane, rotate it, subdivide it and delete the left side. This modeling method works well for symmetrical parts. It saves us time. And using the reference as an example, create a shape. After what we did with the disc at the beginning, this is an easy walk for us, but it needs to be done. In order to place the Brembo logo, I downloaded it from the internet. I came across a vector version, so I'll just add depth to the letters and attach them to the brake housing using Ctrl+P, setting the parent. Well, duplicate the housing and rotate it since there should be two brake pads. And so the part can be installed in place. A very useful combination of Ctrl-L. I recommend you to read it boldly. There are many interesting variations of what exactly you can copy. I also want to take this opportunity to show you that the paint that I used for the disc can also be used for the brakes. But now we use the interactive menu that we have. Here there is very good access to the settings. As you can see, I removed the metal shavings from the paint impurities. And so our lesson is coming to an end. In the next one I will most likely make a tire. What I want to say is that I am grateful to you for joining the world of Blenderism. We can have fun here together, write, suggest, criticize. I am always glad to hear from you. And I want to ask you to check your subscription. Well, as always, learn hotkeys. They will make your life easier. Do not rush. Try different options. And pray for Ukraine. Thank you for your attention. Bye.